Hey everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher, and let us start this video without wasting any time. So the first reaction on your screen is Darzen's reaction. Okay, Darzen reaction. Have you seen that car? Have you seen that car? Tarzan. There was a Tarzan is also a I think cartoon show Tarzan. Right, there is also Tarzan movie, right? That was a very famous movie 15 years back, right? So there used to be a car which name was Tarzan. So now let us see this Darzen reaction. From that you can remember this. Here what we actually do is we have alcohol and we add thionyl chloride. Okay, this SOCl2 is thionyl chloride. Thionyl, because they can also ask you, because student, SO2Cl2, this is sulfuryl chloride. This is sulfuryl chloride, right? So you need to be you should know the difference between what is thionyl and what is sulfuryl chloride. This is used in Darzen reaction. This is used in Darzen reaction, and sulfuryl chloride is used in Reed's reaction. Okay, that is used in Reed's reaction. So now you need to focus on these reagents as well. What is the reactant? What is the product? So in case of Darzen reaction, the reactant we have is ROH. And in this case, the reactant that we have is RH. That means hydrocarbons or alkane are in the Reed's reaction. But in the Darzen reaction, you have alcohol. The products are completely same. That is, you have RCl, SO2 and HCl. Now, this is why this is a very useful reaction, because here vapors are formed, right? The byproducts are also vaporizable, so they can convert themselves into vapors only. So it will be very easy for us to separate this product that we wanted, right? So that is why this is a very, very useful reaction. Okay, yes. Now, next is Sabatier-Sanderson reaction. Guys, just ignore these stupid people here. Let's not, let's not get our mood bad, or let's not get, because of these stupid people, let's not spoil something that we don't want to spoil. Okay, let's focus on this thing. Okay, yes. They are brainless people, so just ignore them. Right? Okay. How to ignore them? By putting your comments in the comment section, in the chat box, right? So in that way, I also won't be able to see their comments, right? Okay. Yes. That was Darzen reaction. Darzen reaction and Reed's reaction are very, very similar to each other. That's why I have shown you this thing, right? In Darzen reaction, we also use pyridine here, right? Then we have Sabatier-Sanderson reaction. In Sabatier-Sanderson, this is basically a hydrogenation reaction only, right? This is nothing but a hydrogenation reaction, right? So in this hydrogenation reaction, you have alkene or alkyne. Now this alkene or alkyne is converted to alkane only with nickel as a catalyst. So if you're using nickel as a catalyst, then you have to elevate the temperature to 200 degree to 300 degree. Approximately, it is studied that with alkene, you just need 200 degree around Celsius temperature. But with alkyne, you need more temperature here, right? And here you have the formation of alkane. If you use platinum here, then you don't need elevated temperatures here. But this particular reaction is for nickel only, right? Okay, yes. Yes, students. Yes, Darzen reaction was basically you have alcohol. OH is converted to this OH is converted to this Cl. That means alcohol is converted to alkyl halide in the presence of in the presence of thionyl chloride. Thionyl chloride is used in Darzen reaction where the reactant is ROH. But in Reed's reaction, there is little difference, right? We use sulfuryl chloride, which is SO2Cl2, and here the starting reactant is hydrocarbons, that is alkane, not alcohols. That is a very slight difference between Reed's and Darzen reaction. Okay, now the third reaction, guys, today we need to complete 60 reactions here, right? Okay, so let's focus. Okay, Now, the third reaction is Wurtz reaction. I'm not only going to tell you the reactions, where the reaction is important, only the reaction, reactant, reagent are important. I'm going to tell you only the reactant, reagent. But where the mechanism is also important, then we will also study the mechanism in those naming reactions. Because in some naming reaction, the mechanisms are as well as like important for you, right? The questions are also asked from mechanisms, right? So now let us see the Wurtz reaction. So in Wurtz reaction, basically what you have, in Wurtz reaction, you have alkyl halide, right? Now, and you are using sodium metal here in the presence of dry ether. First question that can be asked is, why you have used sodium? Sodium so you have used, but why you have used a dry ether here? What is the use of dry ether here? So why we have used ether is because this sodium, right, this sodium with this ether, suppose this is the ether, it will have the solvation energy, right? So many ether molecules will be present here and they will have the solvation energy. Because of this solvation energy will be released and it will be easy for the reaction to occur. Second thing is, why dry ether is used? Why not simple ether is used? Because in the dry ether, right, when you talk about sodium is very reactive with the moisture and the air. That's why we keep sodium in kerosene oil, right? So that's why we use dry ether. Even in Grignard reagent reactions, we use dry ether because Grignard reagent is also very reactive with the moisture or the air, right? Okay, so that is why this is used. Now that was about the reaction, that you have 2 alkyl halides, you have sodium. Now this will be eliminated and you will have the formation of RR. But here the mechanism is also important. Why the mechanism is important? What is the intermediate that thing is important for you? So as you can see here, the intermediate that we have here is free radical, right? Because of this, we'll be able to answer the questions from Wurtz reaction, Wurtz-Fittig reaction or Fittig reaction. In all these cases, you have free radical as the intermediate, right? So now this is your intermediate that is formed. Why? Because of homolytic cleavage, you have the formation of free radical, and now these two free radical molecules will combine to form RR. Now, important thing is free radical is formed here. Next important thing is double the number of alkyl chain is formed here, right? And we are saying that symmetrical and even number of carbons are possible. That means propane is not possible here. Methane is definitely not possible because double the number of carbon chain is formed. And methane is only 1 carbon. So how can we double it? We can't use half and into multiplied by 2, right? There is no half carbon that exists, right? So that's why methane is not possible. All the other odd number are not possible. Odd number of carbon are not possible. Unsymmetrical alkane are not possible. Here only even and symmetrical alkane can be formed from this reaction, and this is called symmetrical and this. Now next important thing about this reaction is that if you use these two things, okay, with the help of examples I'll tell you. For example, they have given you these kind of reactions, okay. One, so they can give you very simple reactions, very simple reactions like this, okay. Very simple reactions they can give you like this, that you have CH3, CH2, Br. Now you need to tell us that what is formed here. So we know what is the reagent that will be formed, that is CH3, CH2. These kind of two molecules will be formed, and after that they will combine with each other to form CH3, CH2, CH2, CH3, right? It was so simple. But now if they want to ask you question of neat level, right, a good question if they want to ask you, then what they will do? They will ask you that, okay, this is the reaction, you are doing Wurtz reaction here, what will happen in the answer? So very simple thing, right? Firstly, just remove the halogen atoms here, and from this we know that homolytic cleavage will occur here, and here you will have 1 electron, here also you will have 1 electron. So you can make something like this. This will be the double bond will present here only, and instead of this Br you will have a free radical here. Instead of this Br, you will have a free radical here, right? Now, two things can happen, intermolecular and intramolecular. And always intramolecular is more stable as compared to intermolecular reaction. Ma'am, what do you mean by inter and intra? Ma'am, I don't understand. So, very simple thing. See, two things can happen here. So, I am writing it here. What is intermolecular? Intermolecular means between two molecules. So, right, you will have two molecules of this and they will combine together and they will make something like this. They will make something like this. Okay, how they will combine together? You can just form it like this. This is one free radical. This is another molecule, right? This is intermolecular. When two molecules are combining together. Now this free radical will join, this free radical will join and they will form this kind of single bond here, right? This is by intermolecular. This is by intermolecular. What about intramolecular? What about intramolecular? When within the molecule, these two free radicals are combining with each other, then they will form something like this. Can you see? They will form something like this. These two free radicals will combine and they will form a bond here, right? Now, which is more stable? I am telling you that usually intra is more stable. Like, I'll do the same thing for this thing, then I'll tell you which is more stable, which is the major product. Similarly, for this, I have CH2, CH2. This is my Br, this is Br. That's why there will be a free radical here. There will be a free radical here. Two things can happen here also. One is intramolecular, one is intermolecular. If I say intermolecular, there also can be intramolecular, right? With intermolecular, what can happen? Two molecules will combine together. That means this will be CH2, CH2, free radical, CH2, CH2, free radical. They will combine together like this, they will join together like this, and you will have the formation of these bonds here. Okay, you will have the formation of these bonds here, right? This butane is formed, this cyclobutane is formed in intermolecular. But with intramolecular, when they will combine together, you will have the formation of this. Now, very important thing I am telling you, that usually intramolecular is stable. So here, I will not even see intermolecular. I'll just see, okay, intramolecular. This is not, intramolecular should not be anti-aromatic, because anti-aromatic is a very unstable compound, right? If you ever see that anti-aromatic is forming, so you will just stop that reaction. Nobody on this planet wants to be anti-aromatic because it's the most unstable species, right? So you'll just see, okay, this is ethene, this is not anti-aromatic. So yes, this is the major product, right? Always just see what is intramolecular product, then see whether it is anti-aromatic or not. If it is not anti-aromatic, then definitely it is a major product. But here, as you can see, this is the intramolecular product, but this is anti-aromatic also. How? Because here planarity is followed, complete conjugation, cyclic, yes. But how many electrons? 4n pi electrons, because it has 4 pi electrons. That means it is anti-aromatic. When something is anti-aromatic, it is very unstable. So this reaction will not occur. Rather, this reaction will be supported and this will be your major product. Okay? This is going to be the major product. Got it? Everybody in the chat box, got it or not? What is going to be our major product when you have these kind of situations, right? Okay. Ma'am, is it important to write down class notes? No, no, Vinutha, don't worry. I'll provide you the notes on Telegram channel, okay? If you write, then you will miss out to so many things here, right? Okay, because I am doing fast track revision we are doing here, right? So just listen what I am saying, okay? Just focus here, right? Okay, next is, this is your Wurtz reaction. Wurtz-Fittig and Fittig reaction are very similar to Wurtz reaction. Let us see how. See, just imagine Wurtz as alkene and Fittig as aryl. Okay, Wurtz is a normal chain and Fittig is a aromatic ring. Wherever you will see Wurtz. Now here you have seen only Wurtz. That means both will be the alkane parts. That means both will be the alkyl chains, open chains, simple chains. But when you see Wurtz-Fittig, one will be alkyl part, other will be aryl part. Everything else is going to be same. This is going to eliminate, that is minus NaX. Then you will have the combination of this R over this benzene, and you will have the formation of this aromatic derivative, right? That is called Wurtz-Fittig. But when we talk about Fittig reaction, Fittig means aryl ring. So now there is no Wurtz. That means both of them will be aryl only. Okay, so now this is also your aromatic, this is also your aromatic. Now again, minus NaX will be subtracted from this side, right? This will be eliminated, and you will have the formation of biphenyl or diphenyl. Okay, you will have the formation of biphenyl or diphenyl. That is your Wurtz-Fittig and Wurtz reaction. Next is soda-lime decarboxylation reaction, a very, very important reaction. Usually it is asked, frequently asked question, okay? Now, first is what will happen here, right? 2-3 things to notice here. One thing is soda-lime. Soda-lime means you have caustic soda, that is NaOH. You have lime also, that is CaO, that is quick lime. Okay, so now these are used, and also here you have the carboxylic salt, sodium salt of carboxylic acid, right? Now Kolbe's reaction, that is Kolbe's electrolysis and soda-lime decarboxylation, they are quite similar, but there is major, big difference in these two things where students get confused. Okay, so you need to see those differences here. First thing is, here definitely carbon dioxide is eliminated, everything is right. But what is the product form, that is important for you. The product formed is R, and here you will join just one H here. That means if you see the alkyl chain in that carboxylic salt, right, this is the alkyl chain, the same number of carbon will be formed as the alkyl chain. This carbon will be eliminated. This carbon will be eliminated, and this R and this H will join together, and you will have the formation of RH. But when you talk about Kolbe's electrolysis, if you talk about Kolbe's electrolysis, I will also show you the comparison here. If you talk about Kolbe's electrolysis, see the reactant is same, RCOONA. But the answer here is RR. Okay, that is the correct answer, RR. So RR means when this will be taken out, when this will be subtracted, this will be liberated, carbon dioxide is already liberated. Now this R part will be double, right? The answer will be the double of the alkyl chain, right? So here the answer is RR. There the answer was RH. That is the difference, okay? That is the difference. Now let us see what is the important point here. Next important point here is intermediate is carbanion. Okay, this you need to remember, because whenever they ask you about soda-lime decarboxylation, if a direct question is asked, you need to remember this thing. And if a complicated question is asked, not even complicated, I would say a good level question is asked, they will ask you question related to this carbanion, right? How carbanion is formed? Let us see the mechanism here. As you can see in the mechanism, here firstly, this will be splitted into the ions, that is RCOO negative and Na positive. Now from this, the electron will jump here, this bond will jump on the R, and hence you will have the formation of R negative. This is the carbanion. That is why the stability of this reaction will depend on the carbanion stability, right? And now this R negative will combine with H positive, you will have the formation of RH, right? Okay. And hence, they can ask you the question like rate of reaction, right? They can ask you the question like what is the rate of the reaction? Okay, ma'am, not understood major and minor product. Okay, I'll tell you after this reaction. Okay, I'll tell you after this reaction. Rate of reaction. Now, rate of reaction will depend on the intermediate. What is the intermediate that was formed here? That was the carbanion. That means rate of reaction of this particular reaction will depend on the carbon ion stability. Now, I told you when we were doing GOC that carbon ion means stress, right? Carbon and carbocation means money, right? More the money, it's better. But more the stress, it's not good. So, carbon ion is negative. So, whenever we talk about the stability of carbon ion, if you are giving the electrons to carbon ion, you are donating the electrons. That means someone is already under stress. You are giving them more stress. Then what will happen? They will become very sad, no? Or they will become happy that yes, you are giving me stress, I am happy. Now, when you are taking away stress from someone, they will become stable, they will become happy. That means here we need electron withdrawing groups. We don't need electron donating group. That will tell us the stability here. So if you talk about the stability, this is A, this is B. I want to see the answers in the comment section. Now, this will be negative, positive, negative, positive. That means this is the carbon ion that we are talking about. Now, as you can see here, this is going to give the electrons. This is going to take the electrons. Now, here one more important thing. One more important thing. Halogen. Halogen. Okay. Whatever I am speaking here is worth coming in exam. Okay. So, halogen. Halogen is showing minus I and plus M effect. Both it is showing. But minus I effect is more dominating. Usually mesomeric effect is dominating everywhere. But it's the only exception where inductive effect is dominating. That is why usually students get confused that ma'am it will have lone pair, ma'am, it will donate the electron. Oh, no, 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 no. In this case, inductive effect is more dominating. So it is a deactivating group. It is a deactivating group. That is why it will take out electrons from here. Whenever someone is taking out electrons, we are giving the stress to them, then we become more happy. So B is more stable as compared to A. That is why rate of reaction in B will be more as compared to the rate of reaction in A. Okay, understood? Okay guys, first you tell me, is this thing clear? You know, now see, Vanutha was asking a previous question, but now I have jumped to the next question. That's why I am asking that whenever you feel that, okay ma'am, we are clear on this, just tell me in the chat box. So that because I will not come again and again back to the reaction. Okay. So whenever I ask you, just let me know in the comment section that yes ma'am, we are clear on this. You please continue with the next one. Okay. Yes. Now let us see the question that Vanutha was confused about. Now let us see this. Okay. I was telling you that one question is a simple question they can ask you. Always how to solve Wurtz reaction. Firstly, make a free radical, then combine two free radical, right? Answer you will have. You make a free radical, combine two free radical, you will have the answer, right? But if you have two halogens in one reaction only, in one reactant only, now that means this will be the free radical. In this case, two possibilities we will have, intermolecular and intramolecular. Usually, intra is always stable. Intra is always the major product. Intra. Now, as I can see here, this is inter, this is intra. I am telling you that intra is always the major product. So, blindly you will just write, okay, intra is the major product, right? Okay, because we just combine these two dots together, it will have ethylene, ethene. This is the major product. But if your intra product is anti-aromatic, then this rule will break. Then it will be like, I don't want to get converted to something which is anti-aromatic. Then it will not prefer this path. Rather, it will prefer this path. No doubt it is preferring now inter path, but it is more happy because at least it is not getting converted to anti-aromatic compound. Okay? Understood? Yes. Okay? How intra is formed? Intra is formed by this thing. When in one molecule they both combine together. This is intra. These two dots are combining together. Intra, within the molecule. These two dots, these two free radicals are combining together. Here also when these two dots will combine together, this is your intra. Okay? Understood? Okay, now next is this one more reaction based on the decarboxylation, soda lime decarboxylation. We can also prepare benzene from soda lime decarboxylation, right? For example, you are using this reactant. Here again, what will happen? You are using this. What will happen? CONA. This will be eliminated as Na2CO3. And what you will be left with here, you will have the addition of hydrogen and you will have the formation of benzene here. So benzene can also be formed by soda lime decarboxylation reaction. Okay. Next we have Kolbe's electrolysis. Now, as I was telling you that in Kolbe's electrolysis, this is this is quite similar to soda lime decarboxylation, but things are very different here. And don't get confused between Kolbe's reaction and Kolbe's electrolysis. Kolbe's reaction is a reaction of phenol. This is Kolbe's electrolysis. They both have no relation with each other except for the scientist. Okay. Now, Kolbe's electrolysis, we are using the same, that is sodium salt of carboxylic acid. Now, here we are doing the electrolysis. Whenever there is electrolysis, what you have at anode, at cathode. We know that at anode, there is loss of electron. At cathode, there is gain of electron. So, can I write here? Here you have loss of electron. Here you will have a gain of electron. Now, when you are losing that electron, what will happen here? Right? This is the CO, this is your anion. It is going to lose the electron. What will happen here? The electron will shift to this side and one electron will be subtracted, will be taken out from this O negative. Right? Now, this oxygen will be left with only one O negative. Now, ma'am, do I need to remember the full mechanism? No. Right? You just need to remember few things here. That is, this is a free radical mechanism. Okay. First thing to remember here is, this is a free radical mechanism and the questions will be same as Wood's reaction only. Right? So, this is a free radical. Soda lime decarboxylation, the intermediate is carbanion. Here the intermediate is free radical. Right? Okay, that is why we have the formation of RR. Because here R free radical and R free radical will combine together. Right? Next important thing to remember here, that at anode you have the formation of carbon dioxide. Right? Because what will happen once you have this free radical, again homolytic cleavage will occur here. Right? And here you will have the formation of R free radical. When this will go to this side, you will have the formation of C double bond O free radical and this free radical. Now, these two free radical will combine together. It will be a situation like this. Okay. It will be a situation like this, that you have C double bond O, free radical here, free radical here. They will combine together to form carbon dioxide molecule. And hence, carbon dioxide will be eliminated at anode. Right, this they can ask you, which is eliminated at anode. What they can ask you, what is the intermediate, that is free radical. At cathode, there is gain of electron and hence here you will have the formation of H free radical. How it will be formed? Basically, you will have this thing, right? Okay, here you are gaining the electron. So, what will happen? It will gain the electron and firstly, so this will happen, this will break and you will have the formation of OH free radical, H free radical. When this will gain the electron, it will become OH2 free radical. So, it will become a negative here. That is why you have OH negative and H free radical. Right. Now, once you have OH negative, H free radical, this OH negative and the Na positive here, they will combine together to form this. That is why we will say it is a basic medium. After the reaction, the medium will become basic in nature. Second question that can be asked, this is at anode, this is at cathode, this is at anode, this is at anode. Okay, this can be asked to you. Okay guys, got it? What can be asked? Free radical mechanism. Next is what is at anode, what is at cathode, this can be asked to you. Right? Now, related to free radical mechanism, what kind of questions can they ask? Right, firstly let me show you what kind of question. Now this is the question they have given. They are saying that you are doing Kolbe's electrolysis, you are adding water, you are doing electrolysis. By this you should be clear that okay, if COONE is given and there is electrolysis, that means this is a question of Kolbe's electrolysis. You need to see the reagents as well. Now what you do, just eliminate this thing from here. What you will get a free radical like this. Okay, firstly make a free radical like this and you will have the formation of this free radical. This is the free radical that is formed. Now this free radical will combine with the same molecule, right? Okay, they two will combine together and they will join together and they will make a single bond here, right, which will look something like this. This is the answer that you will have. This is the alkane that will be formed in this case. Got it? Firstly, in Kolbe's electrolysis, you will make the free radical. Then two molecules will join together. Then you will get the answer. It is same as Wurtz reaction, same. Okay. Now with the same reaction, with the same reactant, if they have given you NaOH, CaO, can you tell me what will be the answer? If the same reactant is given, but the answer will be different here. This is soda-lime decarboxylation. What will be the answer here? CH3 will remain as it is. Here carbanion is the intermediate. This will be removed. Instead of this, you will have hydrogen here. That means this thing. Or hydrogen, so we don't even need to mention. So this will be the answer. Okay? This will be the answer. This will be the answer for soda-lime decarboxylation. Okay? Yes. Yes, yes, yes. Varuta, let's focus on one thing today, okay? That is naming reaction. Now, next question is Reed's reaction. As I have already told you, this is similar to Darzen. Here we are using alkane as the starting product, right? You will get alkyl halide from here, sorry, alkyl chloride here, right? What is different? Here you are using sulfuryl chloride. Sulfuryl chloride you are using, okay? Not thionyl chloride. Answer is same, that is RCl, SO2 and HCl, they are formed. The answer is same, but the reactant is different, the reagent is different, okay? Understood? This is called Reed's reaction. Next is Lindlar's catalyst, okay? Now, Lindlar's catalyst, that is basically poisoned by sulfur, poisoned by quinoline, poisoned by CaCO3, right? Or simply they will write BaSO4, right? This will be BaSO4, right? Okay. So anything they can ask you, or simply they can write poisoned by sulfur. So basically what happens here, we know that whenever we have this alkyne, okay, we are doing the hydrogenation. Now, hydrogenation is a catalytic process. So it will be like, I too want to convert this into alkane. I will convert this into alkane. You are like, we don't want to convert this into alkane. We just want to stop to the alkene process. That is why a poison is used. And that poison is called this PbSO4, BaSO4, quinoline, sulfur, CaCO3. Usually they can write just simply poisoned by sulfur so that the reaction can stop at alkene point. Now, next two questions that can be asked from here. One is cis-alkene, one is trans-alkene. So, cis-alkene, this question is a very frequently asked question in your NEET exams, that cis-alkene is formed where and trans-alkene is formed where. Now, when you are using Lindlar's catalyst, doing the catalytic hydrogenation, in that case, you will have the formation of cis-alkene, right? But when you are doing the Birch reduction, in Birch reduction, the answer is different, right? In Birch reduction, the answer is not cis-alkene, the answer is trans-alkene is formed. That means RR will be on the opposite sign, right? Now, what is the reagent of Birch reduction? Either you can use sodium or lithium in presence of liquid ammonia. That you will have the formation of trans-alkene here, right? Trans-alkene will be formed here. Now, guys, let us see this very important thing here, that that I told you about the Kolbe's electrolysis, right? But in Kolbe's electrolysis, and this I'll tell you also in Birch reduction, okay? So there are some things that are not usually mentioned in NCERT, but that are very important for you to note down, right? That is why I have taken up this lecture, so that what is not there in NCERT, you can also cover those things, right? Okay, so now let us see this thing here. We know that simple reaction is when you have Kolbe's electrolysis, this will be double. That means a bond will be formed between these two and you will have the formation of RR. But what if already you have dicarboxylic acid, right? Okay, this may be CONA or maybe COH, whatever is given to you. Now what will happen? You will have the formation of alkene. This will be eliminated, right? And here you will have the formation of a bond. This bond will be formed here. Same thing we are doing, guys. Same thing we are doing. Here also, you have eliminated this. You had R and you had the formation of a bond with hydrogen, right? Now, oh, sorry, not with hydrogen. This is with R. 2R, you have R and this R. They will make a bond and you will have the formation of RR. This you have done here. Here also what will happen? You will have the formation of a free radical here, a free radical here. They will make a bond here and a double bond will be created here. That means alkene will be formed from Kolbe electrolysis if you have dicarboxylic salt, right? But in that you also have single bond there. Now, if you have dicarboxylic salt, but you already have a double bond, again what will happen? There will be a free radical here, they will join and you will have the formation of this alkyne. This will be eliminated. This will be eliminated. Got it? So this is how you form alkyne. Okay? Yes. I think you guys are studying this for the first time or what? Now, okay, I'll show you that again. Guys, see this thing. What I am telling you, that you have R free radical, R free radical. They will combine together to have the formation of R. Okay? This is what we do in Kolbe's electrolysis, isn't it? This is what we do. R free radical combine together, they have the formation of R. We are making a single bond there, right? Now, same thing we will do here. Here also we have eliminated this. We have put R dot here, one more R dot, they combine together to form RR. Firstly, tell me, is this thing clear or not? After this, here also I am doing the same thing. You are eliminating these two COONA or COH groups, right? After this, what you did here? You had the formation of this dot here. Same. Here also this free radical will be formed here. Then they will combine together and you will have the formation of this thing, right? You will have the formation of this alkene, right? Here also I am doing the same thing. This will be eliminated. Here you have one free radical. They will combine. You will have the formation of this alkyne. This is how from Kolbe electrolysis you can have the formation of alkene and alkyne as well. Okay, clear? Yes, everybody, clear? Yes. Now, let us see the next thing. Reed's reaction we have done. Lindlar's catalyst also done. Birch reduction. We were at Birch reduction. In Lindlar's catalyst, cis alkene. In Birch reduction, trans alkene is formed. Right? Now, what other kind of Birch reduction can be there? Right? Little bit good level of question. Okay, just see this. Very, very relaxed. I'll explain you what exactly we are doing here. Right? That is why this lecture is very important. Right? Because I have collected like full material that is required for you. Right? You don't need to do anything apart from what I am doing today. Right? Okay? So everything you will see, it's not okay, my students should feel this is easy. Easy to everybody can do. Right? You should also know these concepts. Right? What's the bad thing? You guys are like, okay, ma'am is doing something difficult, I'll just go and, end this class. This is what you are actually lying to yourself only. If someone is teaching you something that is taught in offline, I'm teaching you that thing on YouTube, you should be grateful for that, okay? And try to understand that, right? Okay. Now, let us see the Birch reduction here. Birch reduction, simple, you have seen here that alkyne is converted to trans-alkene. Done. Now, if they are going to make NEET 2025 paper difficult, right, then what they will do, right? Okay. Yes. Now, beta Birch reduction is in your syllabus. Okay, don't worry. That is in your syllabus, right? So, now let us see this. If they will make a good level of question, this is very simple, okay? Just go through this. Very simple. I to first have to convince you, right? Okay. Now, Varisht in JEE, so there is more, like in JEE, not mains, in JEE advanced, there is more, right? Okay, it is not limited to this only, what I'll do today, right? This is for NEET, strictly for NEET, right? And maybe JEE mains, but not for JEE advanced, right? Now, Birch reduction, see this, you have benzene, right? Here you have Na, NH3, everything is same. See, what will happen? Just remember the answer here. Benzene, one bond will break and you will have on the opposite positions, you will have the double bond, right? On the opposite positions, you will have the double bond. Just remember the answer here. In Birch reduction of benzene or its derivatives, in Birch reduction of benzene or its derivative, answer will be 2 pi bonds. Answer will be 2 pi bonds, right? Now, if you are simply using a simple benzene, then these two double bonds will be opposite to each other. This is the correct answer. Now, if they have given you any electron donating group like this, Now, donating. Achha, tell me one thing. Who is donating something to you? You will be very close to them, right? If someone is donating something to you, donating their notes to you, making notes for you, right? Or giving you previous year questions, you will be close to them or you will stay away from them. You will close to them, right? Because they are helping you. If someone is donating, they are a good person, right? So with the donating, you should be close to them. So these double bonds will be opposite only, but they will be closed. Close means this will be next to the double bond, will be next to the electron donating group. That means if I make the answer here, the answer will be, this is CH3. I need to make double bond on the opposite positions, right? So here it will be close. Either I can make this thing or I can make this thing. Both are the correct answer. Either I can make this thing, because after CH3, this is the only double bond that benzene can have. So opposite to this is this one, right? Or I can make this double bond and this double bond. Okay, understood? Now, if they are giving you electron withdrawing group like NO2, if they are giving you electron withdrawing group like NO2, now they have given you NO2. Now you will be like, what to do, ma'am? NO2 they have given, ma'am, should I do the same? Now if someone is taking out money from you, right? You are like, okay, this is my saving. You went to your coaching or maybe school in your friends group. You said that, okay, I have bought this thing. They're like, okay, give us this thing. They just snatched everything from you, right? So they have withdrawn everything from you. If someone is withdrawing something from you, you will stay away from them or not? I too will stay away from someone who is stealing everything from me, right? So when someone is withdrawing something from you, you will stay one step away from them. So I'll be one step away from them. Again, double bond will be opposite only. Tell me, is this difficult? Is this easy? Is this difficult or is this easy? Easy, no. Very simple. One bond we will break. Other two bonds will always be opposite to each other. In simple, though, we can make anything. You can make this thing. Even this is the correct answer. Even this is the correct answer. All of them are the correct answer. All of them are the correct answer. All of them are the correct answer only. Because the double bond should be opposite, right? All of them are opposite Simple, right? Now, donating double bond, the condition is double bond should be next to them. So, it is next to them. Either this or this can be the answer, right? And here, double bond should be away. So, here away is this one. This is the only position that where it is away from them, right? Okay, simple. So, this is also Birch reduction. Okay, this is also a Birch reduction because you have Birch reduction in your syllabus. So, my idea was, what if they, like, you know, we know that in NEET 2024 what happened. So, let's not take risk. Okay, these things are for those students. See, if you are aiming for maybe 600 marks, maybe 550 marks, 520 marks, I'll be very clear with you. If you are aiming for maybe 520, 600 marks, then you don't need to do this thing. Okay, then why to take, then just ignore this thing, right? But if you are aiming for 700 plus marks, you're aiming from 680 plus marks, right? Then guys, you need to do even these things. Then you can't skip these things, okay? Right? Okay? Yes. Very good. Very good. I'm so happy you're aiming for 720 marks. Then to you can't leave anything. Okay? Then to everything is easy for you. Everything should be easy for you. Right? Now, next question is, next reaction is Wittig reaction. Okay? Wittig reaction. This is also, I would fall. Okay, I am making some, I am making a mark here. The mark is R. The mark is red. In red where I have written decay, you can even skip these reactions. If you don't want, if you are okay with taking risk, then you can skip this reaction as well. You can skip this reaction as well. If you're okay with taking risk. If you don't want to take risk, then you must do this reaction. Okay? Yes. Now, here again very simple. Here you have phosphorus halide. What is very simple? Yeah, very simple. You don't need to see in any mechanism, nothing here. Just remember the reactants and the product that is formed. Okay? So this is Wittig reaction. In Wittig reaction, what we do? This is phosphorus halide. Phosphorus halide is, on phosphorus you have 3 phenyl groups and you have CH2 negative here. Because phosphorus is not able to complete the 5 bonds, that's why it is very poor. It's in like garibi, poor, so positive. CH2 is having negative because see, 3 bonds it has completed, it needs 2 more electrons to complete its octet. So that is why it is CH2 negative. Now simple thing will happen here. What will happen? They will just exchange their positions. This double bond will be shifted to this side, that is double bond O. Everything else is same. Everything else is same. Double bond O is shifted to this side, right? And here one double bond will stay as it is and this CH2 will be shifted to this side. That means it will be something like this. Here you will have CH2 and here you will have double bond O. Okay? This will be eliminated. This is the answer. Okay? And this is the formation of alkene. Okay? Okay. Okay. Understood? Understood, guys? Understood, everybody? Got it? So this is called Wittig reaction. Right? Now, next is hydration of alkene, and this reaction is very important, right? It is, I would say, the most predictable question of your NEET 2025. Most predictable. Reason being, here they will ask you these 3 things. Tricks I have written here, right? Reagents I have written here, right? In all these cases, we will add we will have a double bond, right? We will, for example, we have a double bond like this. To one we will add OH, to the other we will add H. Okay, to the other we will add H. This is the hydration of alkene. But how the hydration will happen, that is a question. Okay, so how the hydration will happen? The first is acidic hydration. If you talk about acidic hydration, that means you will add water in acidic conditions, right? Now see, understand guys, very simple. Here, don't use, ma'am, I will apply directly Markov-Nikov rule. You will get the wrong answer here, right? Sometimes you can get the wrong answer because sometimes actual mechanism is, in the reality, the mechanism is that carbocation is formed. After that, rearrangement can happen. After that, you have the attachment of OH negative on the carbocation carbon, right? And in the third, that is oxymercuration, demercuration, directly you will apply Markovnikov rule, because here you have no carbocation formation, right? In the mechanism, there is no carbocation formation. That is why there is no carbocation, no rearrangement in this case. But here you have rearrangement also if possible. Okay, rearrangement if possible. You can write if possible. If possible. If it is giving more stability, only then you will have the rearrangement. Okay, now what is acidic hydration? You have water H positive. For hydroboration oxidation, what you will have? BH3, that is diborane, right? Then you will have THF, right? Then you will have H2O2 peroxide and NaOH. These are the reagents that you will see, right? Then oxymercuration, demercuration, you will have diacetate, mercuric diacetate, then you will have H2O, then you will have, see, oxymercuration. In oxymercuration step, you will use these things, right? When you are adding the mercury into the reaction, right? In demercuration, you will take away the mercury by adding NaBH4, which is a good reducing agent, right? So these are the reagents, these are the rules, okay? These are the rules. Got it? Okay? Okay guys, we will also do questions based on this when we will do previous year questions, okay? Now, next in Tidden's reaction, Tidden's. So in Tidden's reaction, what you will use? You will use NOCl, right? Now break this double bond. Cl will be attached here, NO will be attached here, and there you will have a single bond. Simple reaction. Tidden's reaction, what will happen? Break this bond, Cl is attached here, NO is attached here on the opposite positions. That is called Tidden's reaction. Okay, yes. Next is Bayer's reagent, right? Very important question, right? Now in Bayer's reagent, you use cold dilute KMNO4, which is 1%. Diluted means only 1% cold diluted KMNO4 you will use. Potassium permanganate is pink in color, right? So how this is a test? Because why we are calling it as a test? Because this pink color of KMNO4 will be decolorized after reaction. That is why this is a test for unsaturation. If you have an alkene and you want to test the alkene, then what you will do here, right? There are so many methods, and one of the method is this oxidation, right? We are using cold dilute KMNO4, pink color will decolorize, right? And you will have the formation, this double bond will break and you will have the formation of OH over here, right? Okay, so basically vicinal diol will be formed. You can even write it. You know what is vicinal? Vicinal means when on the adjacent position you have that group. So diol means on the adjacent position you have OH groups. That is called vicinal diol. Now one more thing that is observed, that brown color PPT precipitates of MnO2 and glycol are also formed here. Right, brown color precipitates are formed here, but this pink color will be decolorized. Okay, that will be decolorized. Now, next is Wacker's process. In Wacker's process, again, these are the reaction of alkenes, different name reactions we have. This pi bond will break, and here you will have the addition of CHO group. Okay, addition means this will be converted into CHO group, and here one hydrogen will be added. This kind of thing. Okay, so this is your CH2 double bond CHO. What will happen? This pi bond will break. Okay, there will be addition of one CH3, one hydrogen here, and here this will be converted to CHO. This is your Wacker's process. Okay, this is called Wacker's process. Okay guys, this is called Wacker's process. Here, these kind of Tidden's, Wacker's, you just need to know the reaction reagent product. That's it. Okay, if they ask you, they will ask you directly the reaction, not detail of this. Right? Now, next is Groove's process. Basically, it is famous by Lucas reagent. right? So what we do here, ROH, right? That is, it is basically the test for distinguished test for 1 degree, 2 degree and 3 degree alcohols, right? So what will happen? You will use anhydrous ZnCl2 and HCl here, right? This OH will be converted to Cl, right? And here, important thing that they ask you in the exam is how to distinguish. So with 3 degree alcohol, the turbidity or the cloudiness, the turbidity is formed immediately, right? When the cloudiness or the turbidity is formed immediately, you will say, yes ma'am, this is a 3 degree alcohol. Now, if the turbidity is formed after maybe 2-3 minutes, right? Turbidity after 2-3 minutes, turbidity after 2-3 minutes or maybe 5 minutes you can write, then this is called 2 degree alcohol, secondary alcohol. For 1 degree, turbidity on heating, first thing is without heating it will not be formed. On heating, on prolonged heating, it will be formed after what time? After maybe 30 minutes, maybe it will take, even after prolonged heating, it will take 30 minutes to form the cloudiness here, right? The turbidity here, right? Okay, so this is how you will distinguish this, right? Okay, this is how you will distinguish the 1 degree, 2 degree, 3 degree alcohol on the basis of Lucas reagent. Next we have Finkelstein reaction, right? So Finkelstein reaction, right? Finkelstein, just remember this, there was a guy called Finn, and Finn was, this is Roxa, right? And this Finn was like asking this Roxa, because usually students get confused in Finkelstein and Schwartz reaction. So there is a trick to remember that, right? Because these questions are asked, right? You have Rx, you have NaI, right? There will be displacement, that means they will replace each other. R will be having this I, right? And you will have the formation of Ri, and this Na and X will form a compound, that is NaX, and this will be precipitated in dry acetone, right? So this is a dry acetone that we are using, and NaCl or NaBr. One more thing to write down here. This X can be fluorine, chlorine or bromine. This cannot be fluorine. Okay, so either it can be chlorine or it will be bromine, right? Now, as you can see here, what will happen? This Rx and this NaI, right? You can just remember this by this thing, that Finn was a guy, right? This was the Roxa. Finn was asking Roxa to apply acetone. Acetone is basically nail paint, right? To apply acetone. But Roxa was always saying no. Okay, Roxa was always saying no. Right? Now, Swati asked Roxa to apply, to do some fashion in life. Then Roxa agreed to her. Okay, Roxa agreed to her. Okay, Roxa agreed to Swati. Right? Now, when Roxa agreed to Swati, basically these are your inorganic fluorides that it can use. Inorganic fluorides can be used here. Okay, inorganic fluorides can be used here, and you will have the formation of RF here. Okay, RF can be formed here after this, because this is very difficult to form. That's why we have a reaction for this. That is Schwartz reaction. These two reactions are your halogen exchange reaction, where you are exchanging the halogen. This is chlorine and bromine. This is also X can be chlorine or bromine, right? Both of them are SN2 mechanisms only, right? Okay. Next, Williamson synthesis, very important, right? From here also frequently they have asked questions in NEET, right? So let us see what is this reaction and what is the highlighted point of this reaction, right? So this is Rx, this is NaOR dash, right? So now what will happen? This X and this Na will be eliminated as NaX, right? And you will have the formation of ROR dash. That means ether will be formed, right? So this is called Williamson synthesis, right? Okay, Williamson synthesis. Now there was a son of William, right? Roxa was interested in William, right? So that's why Roxa left Finn and Swati also, right? And Roxa made with the R-O-N-A, right? Now it has converted to ether. Now they are married and they have converted to ether. Hana? Roxa left X also. She's like, I don't want this X in my life. I don't want any halogen in my life, right? And this R-O-N-A, he left this sodium. Like, I don't want sodium in my life, right? And they both got married and this is now ether, right? Okay. Now, see one thing here, that very important thing, this point. From again, this point also is very important. Reason being that alkyl halide should be primary always. Okay, alkyl halide cannot be secondary. Alkyl halide cannot be tertiary. For example, they are asking that you have to make this halide. Okay, you have to make this halide, this ether. For example, they are asking you that you have to make this ether from Williamson synthesis. What will be the reactant? Now I know that what can be the reactant. One alkyl halide should have X, one alkyl halide should have ONA, right? Now I know that alkyl halide cannot be tertiary. So that is why this alkyl group will have X and this alkyl group will have Na, and hence you will have CCH3, because this alkoxide ion can be secondary or tertiary, but that should always be, halide should always be primary. So this is the only possibility that we will have. This is the only possibility that we will have, right? And this will be the answer. These kind of questions are asked to you. Okay? Yes. Most welcome, Sneha. Most welcome, right? Okay. So these are the important questions. You can see this in your previous year questions as well. This is what they ask you, right? Okay. Now next is, this was 17th, no, 18th is Frankland, right? Frankland. We have done 17 reactions here, right? Next is Frankland. Frank is very frank in life. Okay. So who are very frank in life? Okay. Who are very frank in life? Tell me, who are very frank? These German people are very frank in life, right? Okay. We Indians are not very frank, but in Europe, everyone is very frank. So this jing, you just remember, you can also remember that there is Frankfurt in Germany, right? If you don't have that much knowledge of geography, then you can just remember who are very frank. These Europeans are very frank and Germany is in Europe only, right? So Zn, that is Germany. By this you can remember things. Okay, if you have any other trick, you can always remember that, right? So Frankland is same as Wurtz reaction only, right? Here also you have alkyl halide Zn and this will be eliminated and you will have the formation of RR. And this Frankland reaction is also not for unsymmetrical alkanes. That's why it's not very famous. Wurtz reaction is more famous and mostly they ask questions from Wurtz reaction, right? That's why it's not very famous. But there is one reaction just like this which is very famous. That is Corey-House synthesis. Now what happened in this Corey-House synthesis, that we were able to make unsymmetrical alkenes as well. Unsymmetrical and symmetrical alkanes. And symmetrical alkanes, both we were able to make. Now when we are able to make both the alkenes, unsymmetrical alkanes, that means we are now successful here, right? So here they can ask you one thing, that what is the reagent that you have used? This is R2CuLi, this is called Gilman's reagent. This is called Gilman's reagent. These are organometallic compounds, okay? Gilman's reagent. This they can ask you. Now, ma'am, do I need to remember this formation of Gilman's reagent? This I have just written here, but you don't need to remember this here. I have written here that if student wants to remember, they can remember, but there is no chance that they will ask you this thing, right? Okay, zero chance that they will ask you this thing, the formation of Gilman's. Yes, they can ask you what is required in Gilman's reagent. You should get an idea that some R, Li, Rx, from this you had the formation of R2, Cu, Li. Okay? Right? Important thing about this reaction is it is also applicable to prepare unsymmetrical alkanes. Right? Okay. Then there is diazotization reaction. Right? In diazotization reaction, what you have, right? You are forming from aniline, we are preparing disonium salt, right? Disonium salt we are preparing, disonium chloride, right? Now here the reagents are very important. Firstly, they can give you NaNO2 and HCl. When they will combine together, they will form HNO2. So either they can give you directly HNO2, don't get confused here. Either they will give you directly HNO2 or they will give you NaNO2 plus HCl. Right? Don't get confused. Sometimes they give you this thing, sometimes they give you this thing. This is the same thing only. Temperature is important because this disonium salt is stable in cold condition, that is 0 to 5 degrees Celsius. So this much temperature is required here. More than that, this disonium salt will liberate nitrogen. So that is not required there. Right? Okay. Then why I showed you this reaction. This is not a naming reaction as such. We have seen weird names everywhere. This is not a weird name. Right? This is just like a normal name. Why I have told you this here? Because from this compound, there are so many naming reactions associated with this one. That's why. Now, first naming reaction is Sandmeyer's reaction. Sandmeyer, remember, sand means salt. Okay, because Sandmeyer and Gattermann reaction are quite similar. Exactly similar. Reactant are same, product are same. But the reagent is different. And there is a very slight difference in the reagent. In Sandmeyer, you use salt. Salt means salt of copper with chloride or copper with bromide. If you have chloride here, you will have the formation of chlorobenzene, right? If you have bromide here, you will have the formation of bromobenzene. If you have not chloride, not bromide, you have CuCN, you will have the attachment of CN group here, that is nitrile group will be attached on this position. Okay, nitrile group will be attached here, right? Okay, now these are your Sandmeyer reaction. Gattermann reaction is similar, but in this case Gattermann. Okay, so in Gattermann reaction we don't use, we know Gatter is like gutter. Okay, Gatter is like gutter. So whenever you pass by some gutter is a very dirty place. Okay. So whenever you pass by some gutter, what you will try to smell some powder, good smell you want to have, right? So here we are using copper powder. Instead of salt, we are using copper powder here. So this is the copper powder we are using. And here what you will have the formation of, again, the answer is same, right? Chloro and bromobenzene. Ma'am, can I also prepare one important question that can be asked to you? Can you prepare cyanobenzene from Gattermann reaction? No. This cannot be prepared. Just write it here. This cannot be prepared. Not from Gattermann reaction. This cannot be prepared from Gattermann reaction. Okay, this cannot be prepared from Gattermann reaction. Okay, understood? Next, Balz-Schiemann reaction. Okay, now tell me, whenever we want to have good hair, right, what we are doing with good hair, what I am doing, okay, if I just apply oil on my head, right, I come like this, you will say, ma'am is not fashionable, है ना? When I'll come with very good hairstyle. Now to my hair are not in a good hairstyle condition, but when you see someone with very good hairstyle, you will say they have fashion sense, right? So here Balz-Schiemann. So here she is doing the fashion. She, She means female is doing the fashion. She is like, okay, I want to take care of my hair. I want to have this kind of hair, that kind of hair, right? So now you will have fashion here. Fashion means fluorine here, right? So this is your HBF4, HBF4, and here you are going to heat it and you are going to have fluorobenzene. Okay, this is called Bals-Schiemann reaction. Acha, one important thing here. Usually students get confused in this. If you add HBF4, then you add NaNO2 with copper couple, then you heat it. Now the answer is entirely different. Though this is not a naming reaction. This is not a naming reaction what I am telling you here. Because this is quite similar. That's why I am just writing this here. This is nitrobenzene is formed. This is not Bals-Schiemann. This is not Bals-Schiemann. Not Bals-Schiemann reaction. Okay. This is not Bals-Schiemann reaction. But this question also can be asked to you. Right? Okay. Understood? Right? This is Bals-Schiemann. This is not Bals-Schiemann. But one step ahead we can form nitrobenzene as well. Right? From the same thing. Super tricks? Yes. Okay. Now Hunsdiecker is very funny trick again we have, right? So you remember Swati. Now we have Swati's mother, okay? Now she is Swati's mother. We know that moms are little bit fatty, right? So Swati's mother is little bit golumolu, right? So now this is our Swati's mother. Swati's mother is wearing that silver chain because we to don't like, I am not wearing anything, you know, any silver chain, any accessory I am not wearing. But my mom is always wearing some good silver or good accessory, gold accessory, right? Our moms are always wearing those kind of things, right? You will always see. Now, Swati's mother is wearing this silver ring or chain. Just remember chain. Now, there are bad criminals. Those who understand Hindi, bure chor, those who understand only English, bad criminals. Okay? Okay? So it depends at which language you are more comfortable in, right? So now bad criminals we have, right? Now what will happen? These bad criminals will take the silver chain from the mother, right? And the mom will be like, oh my God, what just happened with me? Mom will like very much, she will get very anxious. That's why what will happen? She will take a big deep breath. Right? So that's why carbon dioxide will be released here, right? And those bad people will take away the chain from the mother, right? Now you are left with, the mother is only left with the bad memories, okay? Mother is only left with bad memories now, okay? Mother is left with bad memories. Mother is like, this happened, that happened. Swati is also sad because of that, okay? Understood? So this is Hunsdiecker reaction. Okay, this is called Hunsdiecker reaction. Any other language? No. Okay. So this is called Hunsdiecker reaction. Okay. Again, next is Dow's process. Dow's process, again, very, very important process, right? Here we should also know the little bit of the mechanism as well, right? So in Dow's process, you have chlorobenzene. First question that they can ask you is, why this is so difficult to break? Why this is so difficult to break? Why you need 623 Kelvin temperature? Why you need 300 atmospheric? Why such drastic conditions you need? Why? Tell me the answer, right? So here we are saying, bro, we are doing this because this chlorobenzene is having these lone pairs, right? That's why it is going to donate the lone pair. Right, that is why there will be a partial double bond character over here. In the resonating structures, you will have the partial double bond character, and that is the reason what we have to do. That is the reason this bond is having partial double bond. It is very difficult to break this, right? First reason is partial double bond. Partial double bond. Acha, tell me second reason. Second reason is, we know that if it has a partial double bond, it has 1, 2, 3 sigma, it is sp2, right? If you talk about a simple alkyl chain, it is having sp3. If you have this kind of compound, it is easy to break this CCl bond here, right? Or if you want to see more clarity, CCl, this is H3, this is sp3 hybridized. It is easier to break this bond here, right? So sp2 is difficult to break. Reason being, sp2 is more electronegative, right? So that is why sp2 is difficult to break as compared to sp3, right? Because electronegativity is more. Third is phenylketone. I am saying even if you say that it will lose Cl negative, it will form a compound like this. Now this phenylketone is not at all stable, right? Phenylketone is not stable. Phenylketone is not stable. So that means definitely any carbocation is not formed here in the Dow's process, right? Okay. So these are the three reasons. Firstly, they can ask you one assertion, reasoning or statement based question on this part of the Dow's process. Second question that they can ask you is the intermediate. They have not asked it yet, right? Okay, it has never been asked, but still just go through this mechanism once, right? So that if they ask you, then you should know. Okay, so firstly I'll tell you that benzene is formed here. Okay, benzene is the intermediate that you should know, because they have also asked the intermediate of Reimer-Tiemann reaction, carbylamine reaction. So it will not be a shock that if they ask you a intermediate of Dow's process, right? Because it's a very unique intermediate it is having, right? So they can just directly ask you maybe 1 second. If you have studied it, it will take you just nanoseconds to answer this, right? Now, you have chlorobenzene. Firstly, you have added base here. What is the work of a base? Base wants to abstract the proton. It wants to accept the proton. So it will take out the proton here and the electrons will jump over here. Okay, there will be 2 electrons that will jump over here. This part will jump here and hence you will have the formation of this benzene intermediate. Okay, this is how first thing is benzene intermediate is formed. After that, when benzene intermediate is formed, see, here this OH negative is acting as a base. But here this OH negative is not acting as a base. Now this is acting as a nucleophile. Okay, here it was trying to take out the H positive. Now here it is not trying to take out the H positive. It is acting as a nucleophile. It will attack on this, right? The electrons will be, firstly the electrons will be shifted here, right? There it will create a deficiency of electron over here. There will be deficiency of electrons over here. So it will attack here and hence you will have the formation of OH here, right? Okay. Till here we have the formation of OH, but what to do with this negative charge here, right? This we need to see, right? So what will happen here, very, very important step. What will happen here? This H will be internally transferred to this negative. This is H positive, this is negative. This will be internally transferred here and here you will have the attachment of this H. These electrons will jump to this O and you will have O negative here. Now you will add Na positive. Now everything is simple. Na positive, this is ONA, then add H positive, you will have H positive here, then phenol is formed. Okay, understood? That is the full mechanism. But ma'am, do I need to remember the full mechanism? Definitely you need to go through the full mechanism. It's not like you can get completely blank here. But what is important for you to remember, that this benzene intermediate is formed. You never know, with these important mechanism they can ask you the question. So you should know that. Okay, understood? Now one more question that can be asked based on this is, okay, when you have chlorobenzene and you are attaching any electron withdrawing group on the ortho and para position, electron withdrawing group like NO2, right? Now it will help it will decrease the drastic condition. The temperature, the pressure you need less. Even if you have on all the sites on ortho and para positions, you have electron withdrawing group, you just need to warm it. You just need to warm it, add water, and you will get the phenol. And you will get the phenol, right? Okay. But if you are doing the same thing, but here the electron withdrawing group is at the meta position. Electron withdrawing group, this question they can ask you, okay? Electron withdrawing group is at the meta position. There is no effect on condition. But here, drastic conditions are not required now. Okay? Got it? Okay. Yes, everybody. Yes, everybody. Hanji. Now, that is done. Next is Ullmann's reaction. Right? In Ullmann's reaction, what we do? Now, it is quite similar to Wood's reaction, right? So, or you can say quite similar to Fittig reaction. But here, instead of sodium, you are using copper. And instead of any alkyl halide, you are using iodine here, right? Now, this will be eliminated. This thing will be eliminated and you will have the formation of diphenyl here, okay? Diphenyl will be formed. That is called Ullmann's reaction. Next is Cumene's process. Again, very, very important process. Very, very important. Very, you will just pick out last 5 years question. Every year, this is like mostly every year this is asked. Okay, now Cumene process. Cumene process is basically the formation of phenol, right? But here what you will have? See, first thing is you will have isopropyl benzene. This is called cumene. This is called isopropyl benzene. Okay, benzene. This is the common name is cumene. Now, in this cumene, when it is reacting in air, right, basically oxidation is happening, it will have the peroxide linkage over here, not COOH, no. This is COOH, peroxide linkage you will see here, right? So, this is COH, peroxide linkage, it has been added here. After this, what will happen when you add water with acidic, with H positive here in the acidic condition? This thing will be eliminated as acetone, and here you will have the formation of phenol plus acetone. That is why both the byproduct are important here, that one is phenol, other is acetone that is formed in this case. Okay, phenol and acetone is formed in this case, right? Okay. Kolbe's reaction. Okay. See, the students have left. This is the patience. Okay, this is, I sometimes feel that students want to get into AIMS, but they don't have the patience to study. Hana? You'll see after just 1.5 hours, they are like, okay, I don't want to study. That's it. That's it for today, ma'am. That's it. Ma'am, okay, no worries, ma'am. You teach good reactions. You teach like everything, but we will not watch. Reason? Because they are so tired. I sometimes feel pity. Why? Because, yaar, who is showing you these dreams then? Huh? Who is showing you these big dreams? That, okay, go, you will see some good motivational video. You will see, okay, you can crack NEET. You can crack NEET in 30 days also. You can crack NEET anytime. You can crack NEET in 1 day also. Right? You will see these motivational videos. Right? But when it comes to studies, I will see only very few people who wants to study. Very few people who actually like that, okay, I want to do hard work to get where I have dreamt of, like where I want to be. For that, you need to do a lot of hard work. You can't be a doctor like that. Right? So, have patience, right? At least now when you are just 5 months away, right? So, have patience, right? Okay? Yes, ma'am, I am JES, but I am watching it is more useful, ma'am. Yes, very good, Varish. Definitely, I am so happy about that. That's the kind of students like Varish, they are here. Why? Right? Why they are here? Right? They are just one month away from JEE because they know the importance of these kind of sessions. Okay? So, don't lose the patience. Right? These 3 to 4 hours are going to be worth it because I am going to teach you all the naming reactions. We are going to do all the previous year questions as well. Right? Hmm. No, no, I'm not skipping dinner. Don't worry. I'll just give you the break. In the break, I'll have the dinner. Don't worry about that. Okay, I'll also give my students a break to have the dinner. Firstly, I'll finish the reactions. After finishing the reactions, before starting the previous year questions, we will have like good break of 20 minutes. Okay. Firstly, let us complete these reactions. Okay. Now, Cole's reaction. In Cole's reaction, what you have? This phenol is converted to salicylic acid. Salicylic acid. Very good for acne. I know it better, right? So salicylic acid, it is converted to. Now here what we do, we add NaOH, it is converted to O negative and positive. Then in the acidic condition, basically, wait a minute, CO2, on adding CO2, right, and H positive, it will get converted to COH. You're like, ma'am, this is pure cramming. What is the mechanism, ma'am? So firstly, let us see the mechanism as well here. This is the mechanism, as you can see, right? This is phenol. Firstly, what will happen, right? On adding NaOH, here it should be NaOH, right? NaOH, it will act as a base, right? What a base will do? A base will abstract H positive from here, right? When the base will abstract H positive, it will become a phenoxide ion. We know that phenoxide ion has a resonance. This electron will be converted here, will be shifted here, this will be shifted here, and hence this is one resonating structure that you will have. Now see, you have the carbon dioxide. We know that in carbon dioxide, this is partially negative, this is partially positive. Now, this is negative, this is positive. That is why this negative is going to attack here, and this carbon dioxide will attach on this position, right? Okay, we know that carbon cannot handle 5 bonds. That's why this bond will shift here, because carbon is not pentavalent. And hence you will have the formation of this thing. We are almost there, right? Now, what we have to do, this bond will shift here, because we have to make carboxylic acid here. So what will happen? This electron will shift here, H will be shifted, this bond will shift here, H is internally shifted to this O negative. What is happening? This electron is shifting here. See what will happen? This electron is shifting here, this pi bond is shifting here, right? Here you will have which thing? You will have this single bond, this is O negative, right? And this H positive will be placed here. And hence you will have the formation of OH here, right? Okay, this bond you will form, this bond will be formed. Here you will have O negative to which H positive will attach, and this thing will be formed. Now, you just need to add Na positive. Firstly, when you add Na positive, because Na positive is already there in the solution. Some students ask, ma'am, why directly you have not added H positive? I am not adding that. It is already there in the solution. In the solution, you have NaOH. NaOH from this Na positive is going to attach here. After I have this sodium salicate, then I know that I will add H positive here with acidification. Then I'll have the formation of salicylic acid. Okay, so answer will be salicylic acid, right? Okay. Hope you don't need to use salicylic acid, ma'am. Thank you, yaar. Thank you. Your wishes, like I really hope your wishes will grant and I don't have to use this salicylic acid more. This has become my life. Okay. Now next is Reimer-Tiemann reaction. So it is quite similar. From phenol you have salicyl aldehyde. Salicyl aldehyde. Okay. Instead of CHO, you have COO. Instead of COH, you have CHO. Now, here you are using chloroform, NaOH and H positive. Very important point about this reaction is the intermediate is very important. Anybody in the chat box, this is your NEET PYQ only. NEET previous year question, a simple question has been asked in NEET. Right? Intermediate is dichlorocarbene. That is CCl2 and this is your carbene. Right? This is your intermediate. Very, very important question. This is your again NEET previous year question. Okay? Yes? Okay. Now let us see the mechanism, how this dichlorocarbene has been formed. As you can see here, how it is formed. First you will have a chloroform. Acha, everywhere I am telling the same thing. Base will do everywhere. You will see all the reaction base is doing the same thing. Base first he will take out the proton. It is proton acceptor. It will take out the proton. This bond will shift here. You will have C negative CCl3. Right. After this, what will happen? This Cl negative will be eliminated. Right. And from there, you will have the formation of CCl2 dichlorocarbene. This will be formed. This is the basically not intermediate. I'll just erase it here. Not intermediate. This is the electrophile. Okay. This is the electrophile. Electrophile means this is electron deficient. Usually students what they think is, ma'am, this is lone pair. Ma'am, how come this is electron deficient? Guys, this is the beauty of carbene. This is not regarded as lone pair, okay? So basically, how many electrons it has? This is C, Cl, Cl and 2 electrons here, 2 electrons here, 2 electrons here. 6 electron it is having. So it is not, octet is not complete here. So that's why it is an electron deficient species, okay? Now, this is the mechanism, okay? Let's go through the mechanism, right? Now, what will happen? Again, doing the same thing here. NaOH, what is the work of NaOH, guys? NaOH is going to take out the proton. Okay, its simple work is to take out proton. Right, so it is going to take out proton. This bond is going to shift here. You will have phenoxide. Then the same reaction you are going to do here. Right, okay. Now, this has changed. In Kolbe's reaction, you had carbon dioxide. Here you don't have carbon dioxide. You have a CCl2. Till here everything is same. After this things will change. After this things will change. Till here everything is same here. Right? So now what will happen? Everyone, now what will happen? This is CCl2. This carbon is electron deficient. This is electron rich. That is why it will attack here. Basically, now here they have pointed the arrow as a wrong arrow. Okay, this should not be the arrow, because it is always towards more electron density to less electron density, right? So from more to less, it will attack here. It will attack here basically, and you will have C will attach here. You will have CCl2, right? Here you will have this H and this, right? Now guys, see one thing, what will happen? Basically this, again here also one thing is wrong. Right, this carbon, this negative should not be present here. Rather, this negative will be present here, okay, on the carbon. The negative will be present on the carbon, okay, not on this carbon, but on this carbon, right, okay. When it will attach here, the negative will be present on the carbon, right, to complete the octet here. Because now it is having 1, 2, 3, 4, 5, 6, 7, 8 electrons. Carbon is happy, I have octet is complete, right. Now, what will happen? Again, the same thing. Hydrogen will, this bond will shift here. This hydrogen will be internally shifted, not internally shifted, yes, it is not internally shifted here. The pi bond it will form here. Here it will form the pi bond. These electrons will shift here, and here you will have O negative. Now this hydrogen is internally shifted to this side. In the Kolbe's mechanism, the hydrogen was internally shifted to this side. That's the only difference, okay? So, here the hydrogen is internally shifted to this side. So, this is CHCl2, this is O negative. Now, once you have reached here, everything else is very simple here, right? There is just one difference. This H is shifted on this carbon here, right? Rather than that oxygen, because it is already present. Carbon is already present. There it will be present after the resonance, right? Now, O negative is present here. Now what you will add? Add KOH aqueous, right? Add NaOH aqueous. We know that NaOH is already there in the solution. Because of that NaOH, this Cl will be replaced by 2 OH, right? We know that one carbon cannot handle 2 OH bonds. It is very difficult for the carbon to handle 2 OH. What will happen here? What will happen here? This is your OH. So what will happen? OH negative will be eliminated. H will be eliminated, right? and this bond will shift here, and hence you will have the formation of C double bond OH, right? This thing will be formed. Got it? What will happen here? I'm going to write it here as well. COH, this is COH. What will happen? H will be eliminated, this bond will shift here, OH will be eliminated, hence you will have the formation of C double bond O, and H is already present here, right? So aldehydic group will be formed, and just after that add just H positive here, right? Okay, and you will get the formation of salicylaldehyde. Okay, got it? Yes. Okay. Okay. Rajkumar, right now just focus on the studies, okay? Nothing will happen if you get demotivated. You are only going to waste your time, okay? Everyone feels demotivated. I know you guys are feeling demotivated right now. But see, there is no use, right? If you keep, demotivation will come. If you keep, you know, if you're not able to ignore that demotivation, then what will happen? You will end up wasting your time. Again, you will be, you will be in that loop that, okay, I got demotivated, I wasted my time, now more demotivation, now more wastage of time, no more demotivation, more wastage of time. You will get stuck in this loop, right? So whenever you feel demotivated, just keep that thought aside. Just tell yourself, ma'am is teaching, I'm going to learn. I am going to learn. I am going to focus. Okay, just focus on that thing. Okay, yes. Now, next is Kirchhoff's reaction. Now, most of you know this reaction, but you don't know that this is, the name of this reaction is Kirchhoff's. Okay, so the answer is Kirchhoff's reaction. Now, what is this Kirchhoff reaction? I'll just tell you. See what will happen. Here you are doing the hydration of alkyne. So, what will happen when you do the hydration of alkyne? For example, I'm using one more example here. This is CH3, this is H. Now you tell me what will happen here. When I do hydration here, this pi bond will break. Okay, one pi bond will break. I'll just break one pi bond. This is CH3. Now can you tell me when the pi bond will break, positive should be on which side, negative should be on which side? If I put positive here, negative here, positive is more stable due to inductive effect of CH3. If I put positive here and negative here, now negative is unstable because of donation of CH3. So that is the reason I am going to put positive here, right? I am just not going to tell you there is positive, there is negative. There is reason behind everything in science. We are studying science, so there is logic behind everything, okay? So this is positive. To the negative, attach one hydrogen. That means this will become H2. Right, to the positive add OH, negative, because we are doing the hydration. So to the negative add OH, right? So this will be the answer, right? Now can you see this is enol form? This is enol form. Now with the help of tautomerism, right, we are going to change the answer, and that is called, not change the answer, we are going to convert it into ketone. Simple trick I told you. 1, 2, ka 3. Okay, 1, 2, 3. What you do after this? First you just write it as it is. Okay, write it as it is. Write it as it is. Okay. Now I am telling you 1, 2, 3. Break the bond of 1 and 2. Attach that bond on 2 and 3. Then this hydrogen is shifted to the first position. You have the formation of ketone here, right? You have the formation of ketone. Break the bond of 1 and 2, then attach that bond to this 2 and 3. This H is shifted to the first side. Okay? Yes. Okay, guys. Dinesh, don't worry. After this, we are going to do the questions, right? Okay? Don't worry about that, right? Okay? Questions you will be only able to do. That's why I have picked out like around 70-80 questions I have picked out for you. Not 70-80, that will be too much. I think around 40 questions I have definitely picked out. Right? Okay. So, if you see today's lecture, like definitely you will see some question, not some question, maybe 7 to 8 question you can easily get from today's, not even 7 to 8, maybe more than that, right? So that you can easily get from today's lecture. Okay, now next is Rosenmund reduction. Anybody in the chat box, what is Rosenmund reduction? Rosenmund reduction. Rosenmund reduction is H2PDBSO4. Again, we are using Lindlar's catalyst, right? Okay. Now what we are doing here? We are converting this hydrogen into, basically, I'll just delete this thing here, right? We can write it in better way. That is, this C double bond is as it is, but Cl is converted to H. That is the difference. This is the Rosenmund reduction. Okay, again, this has been frequently asked in your NEET, right? Okay, next is Stephen's reaction. Stephen's reaction. Everybody, Stephen's reaction. Everybody in the chat box, Stephen's reaction. What do we do in Stephen's reaction? You have RCN. When you add SnCl2 and HCl here, right, tin chloride you are adding here, it is this RC triple bond N. One pi bond will break and you will have the attachment of hydrogen and hydrogen here. This thing is called imine, right? This is called imine. After this, you will do the hydrolysis. This full will be converted to double bond O. That is called ketone. And this full process is called Stephen's reaction. Okay, this is called Stephen's reaction. Okay, this is called, guys, Stephen's reaction. Very simple, very simple. Okay, next is 33. That is Itard's reaction. Again, this has been asked so many times in your NEET, so many times, right? Now, here you have toluene. Okay, the starting product, the starting reactant is toluene. Now, in the toluene, you have chromyl chloride. You will add chromyl chloride. Now, in this case, this you will have the formation. You also use carbon disulfide here, right? Now, what will happen in that position? You will have the formation of this OCr. This maybe this chromium. Not this chromium complex. Okay, you can just use chromium complex. Chromium complex is formed here, right? That is, in bracket you have OCr, OHCl3 twice. Now this whole thing will be converted to double bond O after hydrolysis, right? After hydrolysis. And this is the formation of benzaldehyde with toluene using chromyl chloride. Okay, using chromyl chloride. There is one more reaction like this. If in this you add, you will get the same thing. You will get the same thing. If you add CrO3, yes, CrO3 in presence, I think that was NaOH or something. I'm not sure about that. That was, I think CrO3 was definitely there. I think after this you had NaOH. Yes. Okay. So CrO3, by CrO3 you will be able to answer that. Okay. If here is CrO3 also, then also it is going to give you benzaldehyde only. Right? Okay. But that is not Itard's reaction. Itard's reaction is this one. Okay. That is a general reaction. Then you have Gattermann-Koch reaction. Now, Gattermann reaction was different. Gattermann-Koch reaction is different. Now, guys, in next 20 minutes, I am going to do some very, very important reactions. Gattermann-Koch, Aldol, cross-Aldol, Cannizzaro, Hoffman bromamide. Then you have Gabriel phthalimide, HVZ, Helvohard-Zelensky. And all these reactions are very, very important. So, next 20-30 minutes are going to be like snatch the marks. Okay? Okay, guys? Okay, everybody? Yes, very good. Yes, definitely it is also used to form cis alkene. Okay, from alkyne. Okay, ready for the next part? Now, let us see Gattermann-Koch reaction. Right, just remember this with Koch. OCH. By this you can say CHO. Right? So you can just remember this thing. In Gattermann you had chlorobenzene, bromobenzene from diazonium chloride. But in Gattermann-Koch you have the formation of benzaldehyde. Right? Benzaldehyde is formed. Now this is quite similar to Friedel-Crafts acylation. Right? Why? Because in Friedel-Crafts acylation what we do, here if you use CH3, C double bond of Cl in anhydrous AlCl3, right? You will get the formation of the nuclei, the electrophile that you will get is CH3, C double bond O positive. This will attack here and you will get C double bond of CH3, right? Now, see this very carefully. Do you agree that this is your Friedel-Crafts reaction, right? Now, if I am saying that you need to attach not CH3, you need to attach H here. Because what is this? Tell me, what is this? What is this CHO? This CHO is nothing but this is basically, this is C double bond OH. So that means if I want to do the same thing with the help of Friedel-Crafts acylation, what I'll do? I'll just replace this with H. That means here also I'll replace this with H. Right? That means here also I will replace this with H. Isn't it? I will replace this with H. Now I'm going to tell you a very, very important thing here. Why we are not following this method? Why we are following this method? Because anhydrous AlCl3 or CuCl is same only. Right? We are using CO and HCl, not using HCOCl. Reason is this formyl chloride is not stable, so this reaction will not occur. This HC double bond O Cl formyl chloride is a unstable compound. That's why we need to prepare this in the reaction itself. That's why we are using carbon monoxide CO with HCl so that we can directly prepare formyl chloride in the reaction mixture only. Then this can make this electrophile here and it can directly attach here. Right? Okay. Okay, got it? Right, everybody? Got it? That why we are using this is Gattermann-Koch reaction. Next is two very important reaction, Clemmensen and Wolff-Kishner reduction, right? So here this double bond is converted to 2 hydrogens. Here also this is converted to 2 hydrogens, right? Okay, this is what we are going to do in the Clemmensen and Wolff-Kishner reduction. But the reagents are different. Reactant is same, product is also same, byproduct is also same. But the reagents are different. Definitely byproduct will also be different a little bit. Reagents are different. But yes, the main product and the reactant are same. So guys, see in Clemmensen reduction, right? What will happen? You will use zinc amalgam in acidic condition. But in Wolff-Kishner reduction, you will use hydrazine in basic condition. So this is what is important, that in Clemmensen reduction you have acidic condition, but in Wolff-Kishner reduction you have basic condition. Here we are using zinc amalgam, here you are using hydrazine. Okay, here you are using hydrazine. Okay, got it? Got it, everybody? Got it? Yes, everyone? Yes. Now, next is 2-3 distinguished tests that we have. Tollens test. Okay, Tollens test is basically, actually it is silver nitrate that is formed here. It is in, if you see the oxidation number, that is Ag positive, and here you have Ag 0. So this silver mirror is formed in Tollens test. Basically, aldehydes will give the Tollens test. Okay, ketones will not give the Tollens test. This is a distinguished test of aldehydes and ketones, right? So here this aldehyde is converted and oxidized to carboxylic acid. This is also the preparation of carboxylic acid, you can say. This is also the oxidation of aldehydes, and this also is the distinguished test of aldehydes from the ketones, right? Next we have Fehling test. Now in Fehling test and Benedict. Now Fehling and Benedict are very same, almost same only. There is just one difference here, right? So Fehling test is also applicable for aldehydes only, right? But in Fehling test, in Fehling A solution, there are two kind of solution, Fehling A and B. Fehling A and Fehling B. So if you talk about Fehling A, that is copper sulfate. Fehling B solution is alkaline solution of sodium potassium tartrate. That means this is your Fehling A solution, right? Now this is what will happen, this because of this alkaline, because this NaOH, you will have the formation of Cu2 positive. Now guys, this is giving you deep blue colored complex when we mix Fehling A and Fehling B together, right? After this deep blue color will change into the brown red precipitates, right? Because it will convert this RCOHO into RCO, that it will oxidize the aldehydes, and it itself will be converted into Cu twice O precipitates. That will be brownish in color, right? Now, next thing is, ma'am, what is the difference between Fehling and what is the difference between yes, Yash, you can watch till I teach NEET previous year questions. After that, I will not advise you to watch, because after that we will do NEET previous year questions. But till the time I am doing the theory part, you can watch, right? Now, this in the Benedict solution, right? And one more thing, Yash, if you're preparing for JEE, then some other tests are also like added, okay? Some other naming reaction and tests are also included here, right? But these are definitely there, right? So, if you talk about Fehling test, you have tartrate, right? But when you talk about Benedict test, in Benedict test, you have citric acid. Citrate you will have, not tartrate. You will have citrate here, right? Understood? In Benedict, you will have citrate. In Fehling, you will have tartrate. That is the difference. Okay, other things are very similar, exactly same. Even the reaction is exactly same. Even the answer is exactly same. Reddish, brownish red precipitates. Now, ma'am, why there was this need? Because in Fehling solution, what happened? No, we have to mix those solutions because those two solutions are not stable, right? So they are not very stable for a very long time. So we have to prepare those two solutions before the reaction when we want to do the test, right? But Benedict's test is stable. Benedict's Fehling A, Fehling B will be stable. This basically this is more stable. That is why we can keep this, right? And this can be used anytime, right? Okay, that's why this was done. Okay. Next is Haloform test. Very, very important. Okay. Mark it very, 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 very important. Definitely you will see a question here, right? Okay. Now, firstly, what we do, three things you need to focus here. First is what are the reagents? Then, what is the group that shows this effect, right? Now, and what is formed here? So, firstly, let us see the reaction. Don't focus on the reactant here. You will have any aldehyde or ketone. I'll tell you what are the aldehyde, ketone, or even the alcohol which show iodoform test. I'll tell you that, okay? Firstly, you just need to focus on what are the reagents. The reagents will be either given NaOH and X2, or they can give you NaOX. Now, mostly you will see iodoform test, okay? So, if you place this X, if this X is equals to I, then CHI3 is basically of yellow color, right? Okay, CHI3 is basically of yellow color, okay? So, this is called the iodoform test. This is of yellow color. Yellow colored is formed here. Now, we have seen the reagent. We have seen what is iodoform. This is called haloform. This CHX3 is called haloform. If instead of X you have iodine, then you call it iodoform, which is yellow in color, right? That is important. Now, what are the reagents? What are the reactants that will show this reaction, this test? Okay, mark this very, very important, very, very important, right? Firstly, any aldehyde or ketone which has this group. Any aldehyde, ketone, if it is having CH3 directly attached to the methyl, directly attached to the carbonyl carbon, then it is going to show iodoform test. You need to identify this group. Now, ma'am, what about alcohols? Right? What kind of alcohols? Now, anywhere you see this kind of alcohol, just add hydrogen here. Just remember this thing. Okay. Then break the pi bond, add hydrogen. This is the second condition. Okay. This is the second condition. If you see this anywhere, students cram, ethanol will show. Ethanol is same like this, na? What is ethanol? Ethanol is CH3, CH2OH. That means it is basically CHH. Isn't it the same thing? Can you identify this group here? CH3CH, right? So this is the same group. Wait a minute. If I want to write it in a much better way, then I'll write it like this. Okay. Okay. If you identify this group or this group, you will see it is going to show iodoform test. Okay. Chalo, koi baat nahi. It is going to show the iodoform test. Okay. I just want to decrease the box here, but I am not able to. Chalo, koi baat nahi. No issues. Okay. So these two are going to show the, yes, it is not one of the previous year question. You will see this, I think so many, this has been repeated, like repeatedly the question are asked on iodoform test, right? So this will show iodoform test. This will show iodoform test. I'll also show you the previous year questions here. Okay. It will show iodoform test. Iodoform test. Okay. Next we have is aldol condensation. Right. Aldol Cannizzaro. Right. Aldol Cannizzaro reaction. Let us see that. Okay. Let us see the, thank you so much study. Thank you so much. Aldol condensation. Okay. Aldol condensation again with Diksha ma'am trick. Okay. Again with Diksha ma'am's trick. Okay. Yes. Okay. Shall we do that? Now in the whole session I asked you that you don't need to have notebook and pen along with, just listen to what I am teaching. But can you do one thing now? Can you just take out one pen and one page or any notebook so that you can also write along with me? Because this reaction you won't be able to understand. Why I have not written anything here? Because there are not fixed product that will be formed here, right? There is no direct reaction that I can just say, okay, this is the reaction, this is the general reaction, right? This is a proper step that you have to follow here, right? So let us solve this together, okay? Aldol condensation, right? Firstly, aldol condensation requires which thing? Alpha hydrogen should be present. If alpha hydrogen is present, then aldol or cross aldol is possible. Otherwise, it is not possible, right? Now we will do aldol condensation here, right? Let us do aldol condensation. Right, I am going to just write it here. CH3, CH3, CH3. I'm just going to write this thing here, right? I'll say, ma'am, what you are doing? Because for this, we need two products, two reactants, right? Firstly, what I'll do, just do the same what I am doing. When you have aldol, both the reactants are same. Okay, so how we have to write it? CH3, CH3, just write CH3, CH3, this is, wait a minute, this is CH3, C, double bond O, H, okay. For one part, you have to open the carbonyl carbon. For one reactant, open the carbonyl carbon. For the other reactant, open the alpha carbon. Like alpha hydrogen you should see. Right? That should not be in a closed structure. Right? So what I am saying, in the second molecule, What you should open? There should be alpha hydrogen you should see individually. But you don't need to open this structure, that is C double bond OH. Just write it CHO. Right? Firstly, is this step clear to everybody? What we have to do? Two reactants you have. First you will write it this way, other you will write it this way. Now directly I'll tell you how to write the answer here. Right? After writing the answer, then I'll teach you the mechanism. Right? Because tricks are important for competitive exam. Mechanism, you just need to go through the mechanism. Okay? So focus on the tricks more. Right? Now, here you have, this is the alpha carbon, this is the alpha hydrogen. This is the carbonyl carbon, right? Now understand one thing, what you have to do in the reactant, in the answer, here, write it as it is, write CH3 as it is, write CH3 as it is, then write this carbon. Now this will be O negative, break the pi bond, because we have opened it, that means some reaction we are going to do here, right? That means something we are going to do with this part, right, and this part, right? So let us see what we are going to do here, right? So this will be eliminated. Now mark this as O negative. Place the hydrogen here only. Now attach these two things. Attach these two things. This carbon with this carbon. The carbonyl carbon of one reactant will be attached to the alpha carbon of the other molecule, right? Okay, the carbonyl carbon of one molecule is attached to the alpha carbon of other molecule, right? Okay, so what we are going to do here, when we attach these two, you will have C here. If you want to attach it here, you can attach it here as well. You can write hydrogen here, right? So it will be C. Now C is having two hydrogens here. It is having one CHO, right? This hydrogen is shifted to this O negative. So hence you will have H here. Understood? Understood, guys? This is how you are going to form the products. Are you able to do this? What I did? Attach this carbonyl carbon with the alpha carbon. This hydrogen will be transferred to this oxygen here. And this pi bond will be shifted here. Right? Okay. So, CH3, CH, wait a minute, I'm just going to write it in a small fonts. This is CH3, COH. Convert double bond, or you can just simply say, convert double bond O to OH. Then attach this to this one, right? Okay, then attach this to this one. This is CCH2. Then complete the valency by hydrogen. This is H, this is CH2, this is CHO. Now, this is your aldol product because you have aldehyde and you have alcohol. Now, also condensation. This is proper as aldol condensation. After that, water will also be eliminated. But how the water will be eliminated? See, from the alpha position, from this position, OH will be eliminated. From this position, you will have hydrogen will be eliminated. This bond will be shifted to this side, right, where OH was eliminated. And hence the answer will be CH3, CH double bond, CH, CHO. This is called, so many questions are asked here on this. This is called, for this aldehyde, this is alpha, this is beta. So this is alpha beta, this is called alpha beta unsaturated aldehyde is formed. Aldehyde is formed, okay? Alpha beta unsaturated aldehyde is formed here, right? Okay, yes, okay, understood? Okay, understood? Now, guys, everybody tell me, are you able to use the trick here? Are you able to use the trick here and apply it here or not? Right? Okay? Are you able to use the trick here and apply it here or not? Right? Okay. Shall we move ahead? Shall we move ahead? Right? Chal. Now, next is this one. Very good answer, Harish. My kids are here to answer you. I don't even need to answer you. Because I have my army. They will answer you. Now, this is the mechanism. Now you will find it very tough that ma'am, what is this ma'am? Okay, so don't worry, I'll just go through this. You don't have to cram this, just go through this. Okay, just see that, okay, ma'am is teaching something, we just have to understand. Okay, what if they ask you some statement based question from? Very rare chances, but still, okay, just go through this very simple mechanism. You have this carbonyl. What is the work of a base? So here the base is basically taking out the alpha hydrogen here. This is CH2 and this is H. Base is going to, what is the work of a base? Base was also what base was doing in Kolbe's reaction, what it was doing in Reimer-Tiemann reaction. It was always taking out the H positive. So it is going to take out H positive. This electron will be shifted here. You will have the formation of this electrophile. Right? Now, this is existing in 2 resonance, but it will attack in this way only. It will attack with this way only. Now we know that other molecule is this one. Here this is partially positive, this is partially negative. Now this negative, this is negative and this is positive. They have made the same molecule here, right? So this is negative, this is positive. That is why it is going to attack here. Because electrophile is, sorry, this is a nucleophile, right? So nucleophile is attacking on the positive position here, where you have less electron density. It is going to attack here, electrons are going to move here, you will have O negative here, CH2, CHO. After that, guys, simply what will happen, you will add, wait a minute, you will add H here, H will be added, you will have OH here. After that, so very simple, OH will be eliminated, H will be eliminated. You will have the formation of this Aldol condensation product. Was it difficult? Was it difficult? Simple, right? Simple. What happened? Base did its work. Right after that, it acted like a nucleophile. It attacked on the nucleophilic position. Now you will have the formation of the product. Right? Okay. Next is cross-aldol. 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 Everybody in the chat box. Cross-aldol question has also been asked to you. Now let's be very, very serious here. Right? CH3, CHO, CH3, CH2, CHO. Now let's draw the products here. First is CH3 can also react with its own molecule. So I'll make both as CH3, CH3, CHO, right? But one will show the carbonyl part, other will show the alpha carbon, right? So here these are the 2 reactants. Now I'm going to do it in a fast forward manner, right? This is the carbonyl carbon, this is the alpha carbon. Attach these 2 together. What you will get? CH3, C. Convert this double bond O into OH, right? Then this hydrogen will be as it is. This CH2 will be attached here. This will be the answer. Once you eliminate this thing, you will have the formation of CH3, CH double bond, CH, CHO. This is the first product that you will get. This is the first product that you will get. Okay? First product. Second product is, what if this CH3CHO reacts with itself? CH3, CH2, CH3, CH2, C double bond OH. Then you have CHO. What is alpha here? This is alpha, right? So we want to show the alpha part here. Okay, so sorry. Okay, now am I audible? Now am I audible? Yes, ma'am, audio, ma'am, audio. Ma'am got too busy in teaching the compounds here, na? Okay, now, okay. Now audible? Now. Let me see how many likes you have given to me for this hard work. Very good. Very good. Let's make it to 200 likes, okay? Let's make it to 200 likes before we end the session. Okay? Now audible? Acha. Where we were. This is carbonyl, this is alpha. Attach these two. This double bond is converted to OH. Here it is the CH3 and hence OH will be eliminated, H will be eliminated. You will have the second product here. Right? Is this thing clear to you? Is this page clear to you all? Right? Now I am going to make cross aldol. Okay? So now cross aldol, that means one is acting as carbonyl. For one reactant, carbonyl carbon will act. For the other reactant, alpha carbon will act. Other is CHO, CH3. For other, you have alpha, right? So this is CH, this is H. So this is, guys, this is alpha and this is carbonyl. Okay, this is carbonyl, this is alpha. So shall I just attach these two together? Hana? We should just attach these two together. What you will get. Very good, very good. Try to make the answer. Try to get the answer here. This will be CH3, right? This carbonyl is converted to OH. Then this is H here. Then this is, both are attached. This is CH. This is CH3. This is CHO. Here also I made, okay. So this is the third answer that I'll get, right? After this it will lose water, and what it will get? After this it will lose water and this OH will be eliminated, H will be eliminated. You will have CH3, CH double bond, CCH3, CHO. This is the third product that will be formed. Okay, this is the third product that will be formed here. Got it? Yes. Very good. Last one is do the opposite here. Okay, do the opposite here. I'm just going to copy paste this thing here. Right, do the opposite here. Opposite means which thing? Here, take CH3, CH2, this as the carbonyl carbon, and take the other one, that is CH2, H, CHO as the alpha carbon. So now this is my alpha, this is my carbonyl. I'll just attach these two together, and what I'll get? CH3, CH2, this is converted to OH, H here only. This is attached to the alpha, so it is CH2 and this is CHO. After this, it is going to lose OH, lose this H here. What it will get? What it will give us? CH3, CH2, C double bond, CH-CHO. This is the fourth product that you will get. This is called cross aldol. Okay? This is called cross aldol. Got it, everyone? Got it, everyone? This is called cross aldol, right? Cross aldol. Everybody, is that clear or not? Is that clear or not? Right? Shall I jump to the next reaction here? Cross aldol. Very good. Very good. That is clear, right? Okay, very good, very good. Cannizzaro reaction. Okay, Cannizzaro reaction. Simple. Just convert, if it is self-Cannizzaro, firstly it should have no alpha hydrogen, right? If it doesn't have alpha hydrogen, then this is converted to C, One is converted to basically disproportionation reaction. Okay, you can even write it here, disproportionation reaction. What will happen? One molecule is converted to the same number of carbon, alcohol, and one is converted to, see, you have C, this is H, this is H, this is converted to alcohol. Then other is converted to, with the same number of carbon, you should have the sodium salt or potassium salt, whatever you are adding. So here you are using concentrated NaOH or KOH. If you are adding NaOH, so it will be sodium salt of carboxylic acid. One is oxidized. Why it is disproportionation? Here you are having the reduction. Here you are having the oxidation. That is why it is disproportionation reaction. Okay? Okay? Got it? This is called disproportionation. One is converted to reduction, other is converted to oxidation, right? With the same number of carbon atoms. Right? What is the doubt? Write it down. Now, let us see the mechanism, same mechanism. Firstly, what will happen? This OH negative is going to act as a nucleophile here, not as a base. It will attack here, electron will jump here, you will have the attachment of OH negative. Now, hydride transfer will happen in this place, right? So, after the hydride transfer, what will happen? This is your O negative. Basically, what will happen? This hydride, okay? This hydride is going to transfer to this molecule, right? This hydride is going to, because here you will have the formation of this acid. This hydride is going to shift here, right? And what you will have, this hydride is going to shift here. This will be H. These electrons will shift here. This will be CH3O negative, right? So, hydride shift will happen not internally. This hydride shift is going to happen on the other molecule, right? Okay. Next is, after this, now you will think that, ma'am, here you should attach Na. But in reality, this hydride again is going to shift here. You will have this ion, and then with Na positive, because in the solution you will have Na positive, you will have the carboxylic salt. Right, you will have the carboxylic salt. Mechanism you don't need to get into, but I'm just showing you the mechanism so that you don't feel FOMO that I have not studied the mechanisms. Because you should at least know how organic chemistry works, right? Next is cross Cannizzaro. This is very important because my idea is asking Cannizzaro is a very simple thing. They will ask you cross Cannizzaro, right? Okay. Just give me a minute. Guys, do you have some job? There are so many unemployed people. Give them some job, yaar. Very desperate. Okay. Now, this is cross Cannizzaro reaction, right? Cross Cannizzaro reaction, very important. Again, the same thing, but there is a twist here, right? One will be converted to OH, other will be converted to COONA. But ma'am, which will be converted to alcohol, which will be converted to the carboxylic salt, right? Okay. Then gamers, you need to write your doubts. I don't have those many powers so that I can understand your doubt just by sitting here, right? You need to write that doubt. Now, here see, you have CHO, the one which is having less hindrance, right, will form the carboxylic salt. Now, which is having less hindrance, everyone? Which is having less hindrance? Which is less hindered? This is less hindered now, so this will form the carboxylic salt, right? Less hindered is going to form the salt. Okay, so now this is going to form the alcohol, so this will be C6H5CH2OH. Because the number of carbon will remain the same. Sometimes students, what they do, they will say, okay ma'am, here phenol will be formed, ma'am. Arey, how? Number of carbon will be same, no? So this will be benzyl. Benzyl alcohol will be formed here. Right? Okay? Understood? Yes. Next is esterification reaction. Now in this esterification reaction, again a very, very important thing. In esterification reaction, as you can see here, RCOH, R-OH, very simple esterification. What you will do, water will be eliminated and you will have the formation of RCOO. Basically, it will be RCOOR. Ester will be formed here. But the question is, will this bond break or will this bond break? That is the question, okay? Will these two oxygen are from the carboxylic acid, or one is from carboxylic acid, right? And the other is from alcohol, right? That is the question here, okay? That is why we have to study the mechanism. Otherwise, so this is not a subjective paper, right? So here we will study the mechanism and see which is the bond that we need to break. Okay, so I'll just show you the mechanism and we identify that thing. Firstly, we know that H positive will attack here, this will shift here, this and that, okay, whatever. What you need to focus on? What you need to focus on? Here, this is your OH, this is the OH, this is the OH here. Now, on this place, this OH is eliminated. That is why I showed you the mechanism. This OH is eliminated. That means in the ester, this OR is from alcohol. This RCO is from carboxylic acid. Okay, understood? This OR is from ma'am. Now, ma'am, what kind of question they can ask you? They can ask you this kind of question. This is RC double bond O. This is having 16 isotop. This is OH. This is R-OH. Right? Now they have given me that this is my 18th isotope. This is 16th isotope. This is 16th isotope. Now you need to tell the answer that what will be the correct answer. Which isotope will be there in the answer. We know that this in the ester, this is my R dash, this will R dash. These O and R are from alcohol, so this will be 18. This RCO is from carboxylic acid, so this is 16. This is going to be the answer. That is why this is important. Okay, that is why this is important, right? I am going to give you a break only. Just 5-6 reactions are left. Okay, 5-6. I am so dying to get break. Bhai. I have not eaten anything, not even lunch. I was preparing these notes for you. I haven't had any lunch. Preparing notes, then collecting the previous year question. It took me 3-4 hours. Not 3-4, maybe more than that. It took me 4-5 hours. Yeah. From 12 p.m. I was doing this only. I just had salad and then just joined the class. I thought that okay, I'll give the break at 8 and I'll have some dinner. But now I am so, my stomach is literally starving right now. Okay, now let us see the next one, that is Helvohard-Zielinski reaction. So in this what will happen, right? This alpha carbon, right? This alpha carbon, this hydrogen on the alpha carbon will be substituted by the halogen that you will add here. For example, you are adding chlorine. This halogen will be either chlorine or bromine, okay? So, either, that means you will have alpha mono halo compound. Alpha mono halo compound. Halo carboxylic acid will be formed. That means on the alpha position, you will have one halogen here. What are the reagents? X2, that is halogen in presence of red phosphorus, and water, that is the reagent here. Okay. Next, Mendius reduction. What is Mendius reduction? You have RC triple bond N, right? This is actually a increment, that is ascending carbon reaction. You will have the formation of amine here, but here the alkyl chain was R, but here the alkyl chain is R plus one more carbon, right? So that is what it is called ascending in nature, right? You have more number of carbon in the alkyl chain. What is the reagent that you use here, hydrogen in presence of nickel. But one more thing, sodium amalgam and ethanol is also used here, right? Hydrogen in presence of nickel and sodium amalgam is also used here. RCN is converted to break the pi bonds here, break these pi bonds, attach H2, attach H2. This will be formed, okay? Break the pi bonds, attach H2, attach H2. Next, Gabriel phthalimide reaction. What is Gabriel phthalimide reaction? It's like a gubber, okay? It's like a gubber. So let us see which kind of gubber it is, right? Now, let us see that. This is basically your phthalimide only. You can write here phthalimide, right? This is basically phthalimide. Now here you have KOH, RX, aqueous NaOH and water, and you do the hydrolysis, right? What you will get here, these bonds will break. You will have OH here, and here H2 will be attached, right? And you will have the formation of RNH2. You're like, ma'am, what is the mechanism, right? So let us see the mechanism. Always remember, primary amine will be formed here. Whatever RX you are adding here, to this RX just attach RNH2. This thing will be formed. To this RX, whatever alkyl halide you are adding here, to that X just add NH2. That will be the answer. Okay. Now, mechanism here is very important, very simple also. Firstly, this H will be replaced by K. H is replaced by K, right? Then this K is replaced by this R, right? Because here you have K positive, OH negative, R positive, X negative. So this H positive and N negative, H is replaced by K, K is replaced by R. Now after this, what will happen? Break these bonds, attach hydrogen here and attach OH here. And you will get RCOOH, right? And this is RNH2, RNH2 you will get, that is primary amine will be formed here. Okay? Primary amine will be formed here. Right? Okay. Okay guys, got it? Got it. Hoffman bromamide degradation, again a very important reaction, very important reaction, right? Here what we do, here this will be eliminated. It will just go, it is decrementing of the full carbon, will just eliminate one CO from there, right? So this will be eliminated and you will have RNH2 as the answer, RNH2 as the answer. What are the reagent? Br2 in presence of NaOH. Br2 in the presence of NaOH, that is the reagent. This will be eliminated. That means amide is converted to amine. Amide is converted to amine, right? Okay, amide is converted to amine, right? Now let us see now here one step is very important, right? So let us see that, right? So what will happen here? Now we are just left with two mechanisms. One is Hoffman bromamide, other is carbylamine. Okay, so just 2-3 more reactions we are left with, right? So this is RCONH2, right? Here base will try to abstract the proton, right? And this will jump here and this will jump here, and hence you will have the formation of this kind of compound, right? Now this is Br2. What will happen? One Br negative will be shifted, electrons will be shifted here. This is positive and this is pi electrons, right? So these pi electrons will attack on the electron deficient bromine, right? And hence bromine will attach here. Now you have this thing. Now firstly what will happen? You have base, right? Again base, just like base abstracted proton from this side, base will again abstract the proton here. It will abstract the proton, electrons will again shift here, this will again shift here. Now what will happen? You will have the formation of this thing, right? Now let us see how we have RNH2 formation. Now bromine will be eliminated, right? Bromine, this step is very important. This step is very important. This step is very important, right? Okay, this step is very Very, very important, right? And this compound is very important, right? Okay, isocyanate is formed. Isocyanate is formed, not cyanide, cyanate is formed, right? Okay, now let us see this. This bromine will be eliminated here. This R will, this is internal shifting, okay? That's why this is important. Okay, in carbylamine also you have same kind of step. So what will happen? Not the same kind of step, but something like this only. Now what will happen? This R will shift here, right? RNCO. Got it? RNCO we want to make. That is why this step is important. That is why this mechanism is important, right? Okay? Because of this, till here everything is simple. This step is important. This R is going to shift here. This R is going to shift on this position, right? Then this pi electrons has shifted here, right? Now here you will have the formation of R. This is R. Then you have N. Then you have double bond C. Then you have double bond O. This is called isocyanate. This thing is formed. That is why this mechanism is important, right? Okay. Then you have isocyanate formation. Then you add water into it. Then what will happen? These bond will break and this will give you RNH2 and carbon dioxide. Okay. This step is very, very important. This step is very, very important. Okay. This step is very, very important. Okay. Got it? Okay. This they can ask you which thing is formed here, right? Next is, okay. Next we have carbylamine. Now very, very important reaction. You will see the same kind, similar kind of transfer here, right? Here carbylamine, it is test for primary amine. Test for primary amine. What we do in primary amine, can anybody tell? RNH2CH3L3KOH. Do you remember we have used this in Reimer-Tiemann reaction as well, right? That is why the electrophile is same. Electrophile is same. I want to see in the chat box what was the electrophile in Reimer-Tiemann reaction. I want to see that in the chat box. Let us see if you guys remember or not what I have taught you. Right? Let us see that in the chat box. Right? Now, this is RNH2. This is converted to RNC. Right? This is converted to RNC. Very, very simple mechanism it is having. Right? Okay. So, what will happen? In the first step, you will have the formation of, that I was asking you, dichlorocarbene will be formed. After that, because of these are the lone pairs and this carbon is electron deficient, this will attack on this electron deficient carbon and hence this thing will be formed. That is why nitrogen is having positive, because nitrogen is having 4 bonds here. Carbon is having negative because now it has more electron. Its octet is complete, it is happy, right? Okay. Now this is negative. Firstly, both the chlorine will be eliminated. Firstly, we will eliminate one chlorine here, right? One chlorine is eliminated, right? Wait a minute. Wait a minute. Yes. Now, the base will attack on this hydrogen, right? This proton will be extracted. This bond will shift here. And here you will have Rn and this will be your... this will have the positive here, not the positive, it will have only 3 bonds. But now what will happen? When this chlorine will be eliminated, this bond will be shifted here, right? So you will have Rn, H as it is. Now you will have NC bond here and this only one Cl you will be left with, right? Okay. Now again what will happen? Again what will happen? Because this is... Again, what will happen? This Cl negative will again leave this, right? Now, what will happen? This hydrogen is again base will attack here. This proton will be abstracted. Now, this bond will be shifted here, right? Again, this Cl will leave and you will have Rn triple bond C formation, right? You will have the formation of isocyanide. Got it? Okay. Okay. Okay, so what is important for you to note down here, that dichlorocarbene is the electrophile in Reimer-Tiemann and carbylamine, and this test is applicable for primary amines only, right? Okay, primary aliphatic or primary aromatic amines. Okay, next is Hinsberg reagent. Hinsberg reagent, what is the Hinsberg reagent, guys? Hinsberg reagent is, firstly, this is the Hinsberg reagent. Now we will see with primary, with secondary. This is the primary. This is actually distinguished test of primary, secondary and tertiary. Okay, so this is benzene, right? S double bond O, Cl, right? Now RN R dash H, right? It is with, wait a minute, NH R R dash. Secondary amine, again the same thing, that is S double bond O, S double bond O, Cl. This is benzene. Again the same thing, N, this is R, R dash, R double dash, plus again the same thing, S double bond O, S double bond O. Now you have to see what will be the answer here. Now what will be the answer here? Okay? Okay? Now H and Cl will be eliminated. You will have the formation of Rn, H will be here, S double bond O, this is benzene. Again HCl will be eliminated. You will have the formation of N, R, R dash, this is S double bond O, and this is your benzene. Again there will be no reaction because we don't have hydrogen here, so that HCl will be eliminated. That is why there is no reaction. Now simple way to say this is, tertiary amine will not react, primary amine will react, but because of this hydrogen here, they are alkali soluble. Alkali means NH4OH soluble. They are alkali soluble. Here you don't have hydrogen or nitrogen, that is why it is alkali insoluble. Alkali insoluble. Alkali insoluble. And in 3 degree you will have no reaction only. This is 1 degree, this is 2 degree, and this is 3 degree. Right? This distinguished test is also asked so many times. Okay, this is also important. Got it? Got it, everybody? Got it or not? Yes. Now, next is, and the last one we have, azodides. This is the last one only. Yes. After this though, we will have break of good 20 minutes, right? Good 20-25 minutes we'll have break. And after that, we will again start and finish the previous year question today. So do you guys want to finish the previous year question today itself or not? Because today only we have, completed all the naming reactions. So I have picked out the previous year questions from the naming reactions only. You will not see previous year questions from any other topic of organic chemistry, but only from the previous year questions, only from the naming reactions. Okay? And I want all of you to answer also, right? That will be a fun game that you guys are answering just after revising so much. That will be fun. But before that, we will have rest. Okay? Give yourself rest. Right? Okay? Last naming, basically this is distinguished test, azodide test. So this is diazonium chloride. When you have phenol, this Cl and HCl will eliminate again, and you will have the formation of this benzene, right? This is N, this is N, basically N triple bond, there will be N here again. This will be benzene, and here you will have OH, right? Again, basically it should be, this will be eliminated. You will have, I'm just directly drawing it. This will be N2, right? And this will be your NH2. Now guys, very important thing, phenol, O, it is going to form orange dye, okay? Let us write it in orange pen only, orange dye. Coupling reaction this is called, okay? Amine is going to, not amine, aniline is going to form yellow dye. This will be yellow dye. Okay? Okay, one more question that is asked here. This is basically your previous year question of JEE Mains, but my feeling is that if they can ask you the question in JEE Mains, because JEE Mains and NEET having the same kind of level, so it is possible, high chances, that the same question they can ask you in NEET, right? Okay. Yes, I think its dye was red color. I'm not sure. I'll see that. What is the color of the dye? But I'll tell you what is the reaction, okay? So this is, again, this will be eliminated. Right here you will have N2. This is your benzene. Here you will have O. This is basically beta-naphthol. This is beta-naphthol, okay? And here you will have your benzene ring. Right? So as you have watched the video, now if you like this session, then do hit the like button, share this video and subscribe to this channel. And you're also, if you're preparing for JEE Advanced, then we have Rank Accelerator book for you. That is for physics, chemistry and mathematics, and it has some really interesting questions for you that you can solve to prepare yourself for JEE Advanced level. But if you want to get this book for totally free of cost, then you can enroll yourself to Eklavya batch. In this batch, basically we solve this particular book in the class itself, in the live session. Doubt sessions are taken here. So that will be very beneficial for you if you are getting stuck in the questions of JEE Advanced. If you are preparing for just JEE Mains 2 attempt 2, then what you can do, in the description we have a link, that is JEE Mains attempt 2, just a batch dedicated to JEE Mains 2, right? Click on that, purchase that, because the batch has already started. Students are already enrolled in that and they are preparing, because we have very less time. Don't waste even single minute here, right? Okay then, bacha, all the best for your exam. This is Diksha Kaushal signing off.